So hello everybody, this is Mr. Rittner, and this is a video tutorial I'm putting together to help you guys out in developing your NPP student submission for class. You know, this is a really great opportunity to practice data analysis and how to operate in a Google Sheets document, or better if you can, an Excel sheet. So what you're seeing on the screen in front of you, this is the template document I kind of put together so that you guys can have a place where you're following the instructions and kind of placing all of your work for me to take a look at. So if we read the instructions here, it says use the provided data, so that's a hyperlink. This is a student net primary productivity data that I've put together for you. You will need to make a copy of it in order for you to edit it, but you're going to be using this data right here. We'll talk more about that in a moment. But you're going to create a graph with an appropriate figure caption for either the water or CO2 availability variable. I'm going to walk you through light availability, so you can't use that data for your submission, but you can pick either water or carbon dioxide. Now, if you're unfamiliar with how to format a caption and its purpose, I left you a resource here for figure captions. Please, please, please go through it. So actually here, I'll click it. That opens up a new tab here. I put this together to assist you guys in writing table and figure captions. All right, so figures would include things like graphs, pictures, and maps. Tables is just for tables. But please make sure you're going through this, following all the instructions, making sure, for example, you put the title not on the graph itself, but rather in the figure caption. And we follow the correct protocols for how to set up figure captions, right? So you have an example here with this. This is the graph we're going to develop for light treatment. So you have that as an example, as a model. You also have this ArcGIS map I put together, all right? But making sure that we format things correctly, using the justify alignment, bolding the words, and also making sure this is like a size 10 font. We'll talk more about that in a little bit, but you do have this resource to assist you with writing your figure captions and your table captions. Back on this template document, this is where I'll leave the tutorial video for you. You know, I have an old one. I'm trying to update it right now. But you can always click on this tutorial here, and that'll pull up my NPP data analysis tutorial. And note, I'm really looking for two things. I'm looking for you to submit your summary table of values for your selected variable of study. Again, either CO2 or water availability. And again, make sure you're including an appropriate caption. There's that document again. We'll talk more about what your summary table is going to look like in a second. And number two, you need to submit your graph of NPP values for your selected variable of study. Again, make sure you have an appropriate caption. Here's the rubric I'm going to use to evaluate you guys. So really making sure you have a strongly set up document, and then looking for the error bar analysis over here in tier 3. I did leave you at the bottom here an example. So this is what our data table is going to look like for light availability. I'll show you how we form it in a little bit. But note, I have a figure caption here, right? It's table 1, and then I have colon. Here's my title for that table, and then my description of kind of how we formatted that, or how I formed it, where the data come from, stuff like that. And then my actual values are kind of laid out here. I have my 25 lumens, 50, 75, and 100 lumen treatments. I have mean NPP with the correct units, right? Grams per 75 centimeters squared per week. I have standard deviation and standard error for NPP, and I do the same thing for respiration and GPP. And then at the bottom, I have my graph of that data, all right? Now again, make sure I have appropriately labeled my legend, right? 25 lumens in blue, red is for 50 lumens, and so on. I have light treatment on the x-axis here. I've labeled that appropriately. And my y-axis is labeled mean NPP, and I have the appropriate units there, grams per 75 centimeters squared every week. And again, I have my figure caption now below, but I've made sure it has justified alignment. So if you're not sure what that means, if I go to my align tool up at the top, it automatically starts you off with the left align, but that's not what we want. That's not appropriate here. We want justify, this rightmost option. So I click that, and it spaces it out so it goes from one end of the document to the other. It's also been bolded, and it's size 10 font. All right, but that's ultimately what our data is going to look like for light availability. My task now is to kind of show you how did I actually get that table of values and this graph. So I'm going to go ahead and switch over to my other tab here, and this is the student NPP data. Now you'll notice, right, at the bottom, I have several sheets here. I have a sheet of instructions, I have my light availability data, that's my demo. You can't use that for your final report, but I'm going to show you how to set that up. And then we have water availability, that one you can use. You can also use CO2 availability, but you don't have to use both. You're just going to pick one of those variables. And this materials list is more just stuff for me. All right, so if we were to run this in the lab, you know, our grow pots would have this kind of surface area. That's where that number came from in our units. Let's go back to instructions for the time being. So I'm telling you that while we can calculate GPP, respiration, and NPP, I want you to focus your graphing only on NPP specifically. You will include a summary table of values for gross primary productivity, net primary productivity, and respiration, just like I did for light availability. You'll do that for either water availability or CO2. I did leave this video here that shows you how to add custom error bars if you need assistance with that, although I'll try and show you that in this video as well. For standard deviation, we're going to use the formula STDEV.S. So this is standard deviation for a sample. It's already pre-programmed into Sheets. We're just going to go ahead and use that formula to calculate standard deviation for our sample. There are other standard deviation formulas programmed in there. This is the most appropriate one, STDEV.S. Of course, we need standard deviation to develop standard error. So the formula we'll use for that is standard error is equivalent to your standard deviation value divided by the square root of the count of the sample. And I'll show you how to do that. But square root is a formula, count is a formula, and sample, I'll show you what that looks like. But sample is when we, for the sample, we'll highlight the data values, your calculated standard deviation, and standard error for. It's effectively your sample size. And of course, I'm just reminding you that NPP, respiration, and GPP are all going to be measured as grams per 75 centimeters squared per week. With that, let's turn over to light availability. So our light availability data, all right, I'm providing this to you. We have up here the plants grown under light all the time. We can use that data to evaluate NPP, just like we talked about. Below, we have the plants grown in darkness. Those are the ones we use to calculate the rate of respiration. Now, for my light plants, I had different amounts of light. They were grown under different amounts of light. 25 lumens, 50 lumens, 75 lumens, and 100 lumens of light. So increasing light availability from left to right. And for each treatment, I had 5 replicates, R1, 2, 3, 4, and 5. And for each replicate, I kept track of their initial mass. So for R1, for the 25 lumens, that starts off at 2.7 grams, and then at the end of the week, it had grown to 4.7 grams. And we can do the same thing for the dark plants. I recorded their initial mass for the dark plants and their final mass. So that allows us then to calculate NPP by monitoring the change in mass. So if I scroll down a little bit, I have this kind of table of values here where I want to plug in my data. So the reason I set up the data the way that I did is it's going to make it really super efficient for you to do your analysis. So whenever you're having to develop your own spreadsheets and stuff, I hope you'll model yours after mine so that you get a better sense of how to set these up efficiently. The more effective you are with Sheets, the easier it is to analyze your data. And if you can't use if you have access to Excel instead of Sheets, that's even better. Sheets is just a watered down version of Excel. But Excel also costs money. So anyway, our next step here is we want to start thinking about our NPP values. To do that, I need to find the change in mass for each of the 5 replicates for each of the 4 different treatments. To do that, I could just go through and say, all right, well, I'll take my 4.7, my final mass of my R1 for 25 lumens, and subtract the initial mass, which was for R1, 2.7 grams under 25 lumens. Doing that by hand is going to be taking us quite a bit of time. However, we can save a lot of time by programming a simple formula. So in my NPP table down here, for R1's change in mass for 25 lumens, go ahead and type in an equal sign. That tells the computer that you're going to be developing a formula here. And what you want to do is you want to take your R1 value for 25 lumens, the final mass. So we'll click on that cell, B10 in this case, so the computer knows to grab the value from that cell, which is 4.7. Now remember, to calculate change in mass, it's final mass minus initial mass. So it's going to be B10 minus, and then select this value right here, the R1, the initial mass for R1 under 25 lumens. So now I click on that, and it reads as equals B10 minus B3. Effectively, the computer is going to say, okay, this value in this cell is going to be my B10 value, 4.7, minus my B3 value, which is 2.7. If we've done things correctly, when we hit enter, we should get 2. And that's exactly what we do get. So that's great. Our next step then is we want to program this formula for the remaining cells below. We want the same thing to happen for R2, 3, 4, and 5. I could go ahead and program it by hand like I just did, or I can autofill the formula. The best way to do that is make sure that I've selected this cell right here. This is C27. It's the cell for the change in mass for 25 lumens for R1. Once I've highlighted that, if I'm in Sheets, specifically on a computer, I can see that there's a little blue box at the bottom right-hand corner. When I put my mouse, my cursor, over that blue box in the bottom right-hand corner, it goes from a cursor icon to crosshairs. Go ahead and left-click with the crosshairs, left-click, hold, and drag all the way down. The computer will recognize that you are applying the formula all the way down, and it's intuitive enough to know that instead of applying it exactly as B10 minus B3, it will now convert it to B11 minus B4. So it's effectively knowing to take the R2 final mass for 25 lumens and subtract the initial mass for R2 at 25 lumens. So that works out really well. If you're on an iPad, that becomes, you can't do it in the exact same way. And please understand, I don't have an iPad. The district did not give me one to use. As I understand it, if you're in the iPad, I believe you need to be in the Sheets app for this. If you left-click on your the cell that you want to apply the formula to, highlight the other ones. If you click on the original cell again, it'll open up like a black menu where you have an option to autofill. But that's about as much help as I can be, unfortunately. Again, I don't have an iPad. Your district has decided not to do that, which is just sort of silly. Now that we've gone ahead and programmed these values here for 25 lumens and the change in mass, I want to go ahead and apply the same formula for 50, 75, and 100 lumens. Again, I set up this data sheet very intentionally so that now we can continue to autofill. Once again, I'll put my mouse over the bottom right-hand corner, get the crosshairs, left-click, hold, and autofill that all the way across so I get the change in mass for all of my replicate values. All 20 cells have been filled in at this point, which is exactly what we wanted. So now we're in good shape. And our next step is to go ahead and start thinking about these statistical values at the bottom of the table. I want to calculate the mean change in mass first. So I have these the sample size of 5. I want to calculate the mean value here. The easiest way to do that is again to use the equal sign. However, now we're going to use a pre-programmed formula. For mean, that's the same thing as average. So let's go ahead and type in AVE. It should be doing that for us. Hold on. Normally, and I guess my computer's not going to help me out today, normally as you start typing in the word, it'll pop up with a bunch of pre-registered formulas that it thinks you want to use. Unfortunately, mine's not displaying that right now because it's not. So go ahead though, don't panic. Type in equals average. Okay, if you have your little pop-up menu come up, that's fantastic. You can just go ahead and click on the average one, but you can also type it in manually, just like I did. Of course, I need an open parentheses, to kind of tell the computer that I'm going to be selecting a range of values. So it's equals average, open parentheses, and now highlight the 5 cells that we want to get an average for. So yours should read equals average open C27 colon C31. The computer will read that and calculate the average or mean change in mass for those 5 values. Go ahead and hit enter. And sure enough, we've calculated an average of 1.4. Nice. Apply the formula to your other 3 treatments, just like you did before. And look at that, we now have our mean change in mass. Next step is to calculate the standard deviation for that sample. So let's use equal again. We're going to use standard deviation.s. I left instructions on the right hand side here. So type in std. See, there's that menu I was hoping to get before. We want this one right here, stdev.s, standard deviation for a sample. That is the most appropriate one. I know that there's standard deviation.p. There's also just standard deviation. Just trust me, this is the most appropriate one. So select standard deviation.s. We have an open parentheses. We have to select our range of values. Go ahead and click on this cell right here. This is C27. Left click, hold, highlight all the way down to C31, close parentheses, enter, and we have a standard deviation value of 0.5. Go ahead and select that value and apply the formula all the way across once again. Nice. All right. Last but not least, now that we have standard deviation, we can go ahead and calculate standard error. Once again, hit equals. Now we're going to program this formula right here. Standard error is equivalent to standard deviation over square root of the count of the sample. So we already have the standard deviation, so you can just go ahead and select the cell above. Select, this is C33. Use the slash for a division symbol and type in SQR. We want the square root. Okay. It's asking what do we want the square root of? Well, we want the square root of a count. So we're going to look for the how many numbers are in our sample. So we can just use count as a formula. Left click on the 2 again, C27 cell, highlight all the way down. So we want the count of our sample. Close, close, hit enter, and our standard error is 0.2, which is exactly correct. And go ahead and apply your formula all the way across. All right, so our standard error is pretty small here. Before I wrap things up, a couple of little minor points for cleaning up our data table here. You'll notice that I had installed this sort of black line around it, or a thick black line around here, but we lost it on the edge there. If I want to fix that, I can highlight these cells, go up to the borders option. I want the outer borders option. And as long as you have the right border style, I can pick this option right here. I can reinstall that and clean it up. So it looks a lot better. One other point to keep in mind is our significant figures. All right. Notice that we're not being really consistent necessarily here. We want to round to the nearest tenth because notice all the data I provided was rounded to the nearest tenth. I know it says 4 there. Ignore that. It's really 4.0. Forgive me. It seems to have deleted that. But just to make sure we're all on the same page, just something to teach you guys, we can increase decimals with the increase decimals button if we wanted to, and we can also decrease them. So make sure yours are all going to be in the tenths, the nearest tenth. All right. I'm not going to show you how to do it, but you would do the exact same thing for respiration. You can program the same sort of formula, except now you'd be typing in equals the final mass of 2.5 minus the initial mass of 3.2 for R1. And you should get a similar set of values like I did here. You can calculate the mean change in mass, the standard deviation, standard error, all in the same way. Down here at the bottom, we have this summary table. Again, I've kind of formatted it for us. You can just kind of fill in the numbers. You'll notice I've already filled in the numbers. The best way to do that is to just copy and paste the values you need. So for example, if I'm looking for the mean NPP values, I can go up to the correct row here. I would copy, but instead of going down here and pasting the values, watch what happens if I just paste those values. It gets all screwy. You don't want to do that. So I'll do an undo here. Instead of just pasting, I want to use paste special, and I want the values only. That way it gives me the actual number. The reason it got screwy was because it was trying to import those formulas, and they no longer refer to the correct boxes when I move them down. So I would just copy and paste all of my data into here for NPP, for respiration, and then I can calculate GPP, remembering that GPP is equivalent to NPP plus respiration. And I'll have my nice summary table that I can highlight, copy that, and then go back to my student submission template and add that into the box here and set that up with the appropriate caption. For my graph, okay, you'll see I have my graph set up here for NPP with light availability. The way I set that up is again, I'm doing NPP values. I would really just highlight these first two cells here, or rather these first two sets of cells, these first two rows. That tells the computer what data to use. I can go then to insert. I want to add a chart. Give the computer a moment to put that together. So far it looks good. I don't have a title in here, which is what I want. I don't want a title in the actual graph itself. That goes in the figure caption. And I can kind of start formatting this. So if I go to customize, I can go to chart and axes titles. I don't want chart title. I want to add a horizontal axis, so I can think about as a label light availability. Okay. I also have this weird piece here. I don't know why the computer does this, but it's inappropriate and we don't want it. We also can't delete it. So rather than delete it, I would select, this little box here that says mean NPP with my units. And for text color, I would just set that to white. And that does effectively the same thing as deleting it. For a vertical axis, what I'm going to be doing now is I would actually just go back here, copy that, right? Mean NPP, grams per 75 centimeters squared. Go back to my customization piece, vertical axis. Let me just paste that in there. And now I have an appropriately labeled y-axis with units. And this is looking pretty good. Except I need to add my error bars. Now, Sheets is a little bit complicated with error bars. We need to make sure that we have all of my data as separate series. In this case, it is set up appropriately. Each of these is being treated as a separate series of data. I can check that here. I can see I have a separate series. You're fortunate that's just I set it up appropriately so that would automatically happen. Sometimes you might need to play around with the switch rows and columns feature to get it so that they're treated as separate series. But as long as you have separate series, you can add individual customized standard error numbers, which is exactly what we want. Go back to customize, and I think we want series. Yep, we want series. And in the series menu, you'll see I have error bars, so I'll check that. Now right away, it installs error bars, and it automatically defaulted to percent, 10% error bars. That's not what we want. All right, we have our own specialized standard error that we want to enter there. So instead of percent, let's try this menu here. Let's go to constant. We want to switch that. And what we need to do is make sure that we select each individual series. So now I'm going to click on the blue one, 25 lumens. And instead of having a number value of 10, I'll enter the appropriate standard error, which in this case is 0.2. That'll give me a more appropriate standard error bar. I can do the exact same thing for my 50 lumens. That's also 0.2. The computer will adjust. For yellow, the 75 lumens, that's going to be 0.3. Let the computer adjust. And then finally, we want 100 lumens. Finally, that's going to be 0.2 standard error. And now I have my graph is now essentially completed. I have my standard error used for error bars. And I can go ahead, copy this over, and then add that into my student template. And that's exactly what I did here. That's where I got my table, and that's how I figured out this graph. I would just go ahead and properly format my figure and table captions at that point. Anyway, guys, that's going to do it for this particular tutorial. I hope that you guys found that helpful, and I look forward to taking a look at what you guys came up with. See you later.